Hello good people, I'm going to talk about stereoisomers, chirality and enantiomers. Recall that there are two general types of isomers, constitutional or structural isomers and stereoisomers or geometric isomers. When it comes to constitutional or structural isomers, it is the connectivity of the individual atoms that is different. When it comes to stereoisomers, the connectivity is the same, but the atoms have a different arrangement in space. When it comes to stereoisomers, there are a couple of flavors, and you have already encountered one, cis-trans isomerism. In this video, I would like to introduce enantiomers. Let me start by bringing a compound. And now I'm going to bring in its mirror image. Both of these compounds have two carbons and consist of single carbon-carbon bonds only. So both of these are ethane. In both cases, carbon number 1 is also bonded to bromine and chlorine. And so both of these compounds are 1-bromo, 1-chloroethane. However, they are not identical. If I take the mirror compound out of the mirror and try to align it with the original molecule, I cannot do it. Yes, the bromine and the CH3 group align, but the chlorine and the hydrogen do not. Hopefully this will become a bit clearer with the use of molecular models. Let me change the scene and go away from the drawing board for a moment. Here we have a molecule that consists of a carbon in the middle and 4 different atoms or groups of atoms attached to it. The moment we have a carbon that is attached to 4 different atoms or 4 different groups of atoms, we have a chiral carbon. And the moment we have a chiral carbon, we have a chiral compound. And the moment we have a chiral compound, there is a possibility of stereoisomerism. Let me bring in the mirror image of this compound. These two molecules are not superimposable. The purple and yellow spheres line up, but the white and green do not. And even if I rotate the molecule, 2 spheres will still not line up. Yes, this time purple and white are lining up, but yellow and green are not. These two molecules are known as enantiomers. Although they have the same molecular formula, and although the same atoms or groups of atoms are attached to a carbon, they are not superimposable, and therefore they are not identical. Now let's go back to the drawing board. So let's summarize. Stereoisomers have the same order of attachment, but different spatial arrangements. Chiral molecules are capable of stereoisomerism. For something to be considered chiral, it needs to have a chiral carbon. A chiral carbon is a carbon bonded to 4 different atoms or groups of atoms. It is also known as a stereogenic carbon or center. The mirror image of a chiral molecule cannot be superimposed on the molecule itself. This is similar to the way that we cannot impose the left hand on the right hand. They are mirror images of each other. In fact, chirality means handedness, is something left-handed or right-handed. And the word chiral itself comes from Greek. The origin is the word heri, which means hand. Molecules that are non-superimposable stereoisomers are known as enantiomers. At this stage you might be thinking, this is all good, but how do we distinguish between these two compounds when it comes to their names? Because so far they have the same name. Well, one of them is the right-handed version and the other one is the left-handed version. And we indicate that by using the capital letters R and S, which stand for rectus and sinister, right and left. In this particular case, it is the compound on the left that is the R version and the compound on the right that is the S version. How do we decide which one is the R version and which one is the S version? Well, that is a horror for another time. That is all for now, and I will see you on the flip side.